What's up, guys? This is Hyce, and today we have another reaction video for you. And this one's a little bit interesting and a little bit different than what we typically show off on the channel. Specifically, we're going to be talking about transit type things, specifically Sound Transit's Cross-Lake Connection project that they just finished and recently opened between Seattle and Bellevue, Washington. I wanted to react to this because, one, it's really cool, and two, I actually helped with a little piece of it back in the day. Before I did YouTube full-time and before moving back to Colorado to do steam engine things, my last real job full-time was actually being a design engineer for Sound Transit. And I actually reviewed a lot of the logic that went into the train control side of things that relate to this project. And the reasoning behind it and the reason why I wanted to show it off is that it is unique and a first for the world. They're running light rail trains on a floating bridge now between Seattle and Bellevue. And the engineering challenge that was significant and really interesting. So I thought it'd be fun to get into a little of the nuances there and share a little bit from my transit background. So let's jump into the video. As always, the full video will be linked down in the description below. If you want to watch without me interrupting and pausing, go click that. I'm going to be pausing to talk about the interesting things that they come up and talk about. This is a production that Sound Transit themselves put out that I think is a really well done thing and covers the basics of the engineering challenges that I wanted to get into a little bit deeper as well.
This is the first light rail on a floating bridge anywhere in the world.
We were trying something for the first time and we needed to make it work.
It took a lot of grit, and there's a lot of trial and error as you go through a project like this.
When we face these challenges, there's always the temptation to say, hey, oh, we can't do it like that. Well, maybe we can.
The Homer M. Hadley Memorial Bridge stretches more than a mile across Lake Washington, connecting thousands of people every day between Seattle and East Side communities. Adding light rail on the floating bridge? Now that's a game changer.
This was a huge deal. Anyone who's driven in the Seattle area understands the Seattle traffic problem. It is well known in transit circles that adding transit does not necessarily remove cars from the highway, just like adding lanes doesn't lessen traffic, but it gives you an alternative to skip the traffic. The trains run on a fixed system. They can run at better headways and avoid the traffic altogether. And so this was going to be a huge deal, and Sound Transit, at least when I worked there, it was the nation's largest transit expansion basically in history, with, you know, like something like an additional 100 miles of light rail alignment being planned. And so all these different projects were going off all at the same time, and this was going to be the key one to link the east side and the west side. Seattle is on the cutest narrow little spit of land, and to the west is Puget Sound, and to the east is Lake Washington, and that makes for really challenging infrastructure for this sort of stuff. Trying to move people north and south through the city is quite the challenge, and so a lot of times you'd be forced to go around on 405 through Bellevue or anything like that, and there wasn't really that many great ways to go across the lake. You basically had I-90 and you had 520. And this was originally the bridge across that was the express lanes that typically were used primarily for buses, but again, buses then have to merge into the general system. So the decision was made to retrofit light rail onto this floating bridge. This is a bridge that literally floats. It has caissons and whatever poured in. I don't know the proper civil engineering terms. I'm sorry, I'm a mechanical that played systems engineer for a little bit. But the bridge floats. It is the hollowness on the inside that gives it the buoyancy that it needs. And so they wanted to put light rail on it, and everyone figured out that, oh, we can do that. But again, getting there required solving a ton of complex and interesting engineering challenges. We'll get a little bit more into the train control specific stuff that I helped with, but overall it was quite the endeavor to do, because you're talking about running double track mainline with light rail vehicles on a floating bridge with pretty tight boundary conditions. especially knowing that the Washington State Department of Transportation, WashDOT, needed to maintain a maintenance avenue that a truck could drive down. It meant there was not a lot of space for the railroad alignment itself, and that made designing some of the interlockings, I wouldn't say utter hell, but pretty close. It was quite the fun challenge, and it was really interesting to kind of be involved in those conversations. I was only involved in the project between 2020 and 2023, more realistically like 2021. I was originally hired just to deal with positive train control things, and I quickly got thrown into the fire of, hey, learn all of the logic about light rail signaling because we need a warm body in the place, and you seem like you've got the tenacity for it. So made things a little interesting on my end.
I think of each light rail extension as a jewel because once it opens, the community responds so quickly and so well. My name is Ron Lewis.
Very well said.
And from 2012 to 2018, I was Executive Project Director of the Eastlink project.
I've met Ron at least once. Very nice guy. He did a lot of the big presentations because he was higher up in the organization. But when he talks about the extensions being a gem, he's not kidding. I think that was the most fulfilling and cool part of working for this organization, was realizing that I was having an impact on something that I had experienced my whole life. The traffic in Seattle. Oh God, we got to go downtown. I grew up in Northgate, up here on the northern end of Lake Washington. Anytime it was going downtown, I mean, I-5 is just a dumpster fire. It's not as bad of a dumpster fire as it is in LA, granted, but it's pretty bad. And you can see the setup that I was talking about where Seattle's just kind of wedged between the two bits of water there. And getting to see light rail trains running past where I grew up for the first time going back and seeing that was one of the most fulfilling, cool things that I've ever gotten to do. It's like, oh, I have made an impact on the community I grew up in. It was a great job and a fun place to work too, but when he means that each project opening is a gem, it really is, because it is providing a great service to the greater Seattle community, and that was always very rewarding to me.
Was the gem of those jewels, the Cross Lake connection. And that's what this project provides, a high-capacity transit link and connection to the east side.
But long before
I have walked this entire alignment, by the way. That was one of the requirements. We had to certify all the components had been installed properly, and track serial numbers and all that fun stuff for all the signal equipment. And so over a period of several days, a friend of mine, one of my coworkers, and I had to walk the entire thing. So every bit that you get to ride at 55 miles an hour, we were walking at literal walking pace and then documenting serial numbers at every piece of train control equipment, which is more frequent than you would think. You might see the signals every couple miles. With an electrified railroad, track circuits and impedance bonds and things were a lot more frequent than that. So I got my steps in on those days.
Before light rail construction began on the bridge, engineering experts spent years designing innovative solutions for several unique challenges.
I'm going to say they started in the early 2000s.
A lot of challenges. My name's John Slavin. I'm a civil engineer, and I worked
saw
on this
his
project
name on
for over
emails.
a decade.
The first challenge was weight limitations on the I-90 floating bridge. Too much weight could cause water intrusion.
We're adding a whole bunch of weight to this bridge. Not only the trains, but we're adding the rails that go onto it, the concrete plinths, the overhead catenary system. But we had to figure out how to mitigate that.
We also had to reimagine the way we typically install rail.
On this bridge, we couldn't drill into those because it had all these cables. And if we snap some of those cables, then you hurt the structural integrity of the bridge.
Plus,
so how do you mount a railroad to something that you could not provide a mechanical fastener to? Again, the amount of engineering challenges that were solved to make this happen, and now that it's operating, is wild to me.
Running electric trains means the potential for stray current on the bridge.
We need to make sure.
This is a key point. When they talk about stray current, the way that a typical DC railroad system works, an electric train, is that you have your positive send on the overhead contact system, and the negative return power that has to return back to the other side of the battery, because it's DC, would go through the rails. And so you've got potentially up to 1500 volts, whatever's not been eaten by the train and traction motors. Presumably would eat a lot, but your worst case is the maximum voltage up top. 1500 volts could be potentially seeping through the rails everywhere down there, and you don't want that then wandering off and dealing with things. It's already enough of a pain to work through ballasted track conditions and deal with track circuits and all that fun on not something as unique as this. So, interesting challenge and solved very well.
To make sure that that electrical current stayed between the rails and the overhead wire, because if it leaks out, it can cause corrosion.
And then there's movement. The rails needed a certain amount of flexion while also being connected to a fixed point on land.
So really these 3 different motions means there were 6 different angles of inflection that those rails would have to accommodate.
So this is probably the most complicated bit of engineering that had to be done, was solving that flexure problem. They go into it in a little bit more depth here in just a minute, but the whole thing is the bridge floats. That means that whatever the water does causes the bridge to change its geometry in every single way. Did it rain a bunch and the level of Lake Washington is slightly higher? Is there wind? Is that moving the bridge? Because it's not totally anchored except for at the ends. And so you had to be prepared to maintain a railroad alignment that matched that and wouldn't break. And the solution they came up for it is ingenious. And frankly, I mean, it was really cool. They had a model of the track bridges they're going to talk about in the office back in the day for like the 6 weeks that I got to work in the office before COVID hit. But it was very neat to see. And obviously they had been designing those things for years upon years before I even got there. I want to say they had already done the testing with a full-scale train and track bridge before I even started at Sound Transit in 2020. They originally anticipated opening this chunk of alignment in 2023. Gigantic civil engineering infrastructure project runs slightly over time. Who's surprised? Literally no one. So, yeah.
After years of research and testing, here's what our engineers designed. Instead of using standard rail, lighter rail saves weight on the bridge. These rails were then set on about 9,000 concrete blocks, which...
She says lighter weight rail, and recall that light rail transit is light rail vehicles on regular rail. Usually most of the rail we dealt with was just as heavy as anything the Class 1 railroads would use, typically 136 pounds a yard. So the fact that they used a lighter weight of rail made a lot of sense in this application, but that light rail does not mean that the rail is physically light. Talked about that in a previous video.
Were designed to be lighter and smaller as well.
The concrete plinths that we built, we use what's called lightweight aggregate. Try to keep those plinths, those concrete blocks, as short as possible.
And instead of drilling holes into the bridge surface, we attach the blocks with an extremely strong adhesive.
We used a material called Dex G, which really glues it on really well.
Then a plastic drip cap on top of each
It's going to be very interesting to see maintenance-wise how the adhesive holds up, but some of that stuff's kind of magic, so
wouldn't be a continuous
imagine it'll do pretty
water
well.
that would come from the rail onto the bridge deck.
In total, engineers incorporated more than 10 different design elements to protect the bridge from any potential stray current. And of course, there was the monumental challenge of taking a train from solid land onto a floating bridge.
Trains are on a fixed rail. If they're all bent at just one point, they would snap. So we had to take that point displacement and spread it over a longer distance. Think of uncooked spaghetti. If you bend it at one point, it'll snap. If you take that whole spaghetti and kind of bend it back and forth, it can do a lot of flexing. And the steel rails are a lot like that. Spread that over a larger distance. And we did that by a system called a track bridge.
There are 8 track bridges using...
These are so cool, and I wish I truly understood every little bit of mechanic that went into them. They had the demo, like I talked about, like I had a scale model of it in the office. And I remember like wishing that I could find whatever civil engineer came up with the design and want to talk through it, but I was always focused on the task at hand, as you do. So I never ended up getting the full explanation on it, but the general understanding I have is that it basically bridges the gap and makes the point of tension for the rail when something changes on the water, rather than it being one infinitely small point where, it's bending and is going to break here, and it makes it a much larger span. You're basically bridging the gap between the land and the floating part of the bridge with another bridge. It's the bridge on the bridge. It's the donut inside of the donut with another hole in its center. Knives Out fun. But that way, you greatly reduce the forces going on, and it looks like there's a lot of cushioning in between those moments, so that as these bridges twist and do their thing, you're still supporting the track and supporting the rail and keeping it anchored to hold gauge and hold all of that true and correct. But rather than, I've moved the bridge a foot to the left over here because of crazy wind or something, and it tries to break the rail at the one bending point, you've now got this whole long segment where that rail can shift and adjust as it needs to. It's really an ingenious solution, and I would love to know the particulars. Sound Transit, if you're out there and you're interested in doing media with me, shoot me a message, shoot me an email. That'd be great. I'm more than happy to talk about the good transit things that are going on, because I genuinely loved the organization and they were great to work for. I just wanted to play with steam trains some more, so that's why I moved away.
Existing technology to solve a completely new challenge. The track bridges rely on design components used in retrofitting buildings for earthquakes. Before construction, we put the designs to the test with full-scale models in Pueblo, Colorado.
I had always heard that. I had always heard that they had sent one of our light rail vehicles to Pueblo to the TTC, is it TTC? I forget the name. They've changed hands a couple times, but there's a big railroad testing center where they do all manner of things and crash trains into nuclear flasks and whatnot down in Pueblo, and the FRA does most of its testing there. I had heard that they had done that, and to see footage of it, it's like, yes, they did do that, and they documented it. That's actually really cool.
And on the tracks, and at the end of that, it's like, wow, it worked. It's really wonderful.
The team is really everything, and this has been an extraordinary group of people. It's kind of like a relay race. You do your part, and then you're passing it on to the next group so that they can do their part.
Collaboration is key to any large, complex project, but when you're doing a first-in-the-world type of a project, it's absolutely essential. Sometimes in construction, the designer and the contractor and the owner can kind of be in our own corners, but it really shows how when we come together, we can do great things. It is achievable, but the strength of that partnership is so much greater when we work together. Having these great relationships, being transparent, getting to that platform of trust so we can solve these big complex issues. And I think this project is a great example of how we did that.
Once construction is completed.
Hey, look, there's the interlocking. Diamond crossover, and you can see the two amber aspects saying, hey, no, stop. And then you could see where the slanted lunar or the vertical lunar would be for proceed or proceed across the interlocking. It's interesting that they talk about the collaboration there. There were so many different entities involved in so many different ways. Like many government projects, it turned it into, a bunch of consultants and a bunch of different groups. But the folks that I always got to work with were excellent. I loved my signal counterpart from the consulting world who was helping out on the projects that I worked on. I primarily spent most of my time on the downtown Redmond link extension, which ran from the end of this chunk of railroad up through downtown Redmond. So basically from Bellevue to Redmond, or from Microsoft to Microsoft, as I always like to joke. But I did do a lot of the logic review for specifically this chunk of the railroad, which I don't think they talk about the signal system at all, because of course it's black box magic that keeps the trains safe, but how does that work? Who knows? So I guess I'll see what they say about it, and if they don't say anything, I'll provide some cool detail at the end.
The final stage before opening is meticulous testing.
The
We're
tests go on
testing
forever.
everything with increasing levels of complexity.
The amount of
to make sure
tests.
that ultimately we
He
can
would not
transport our
he would not
passengers
believe
across
the
lake,
amount of tests that they
on
do
a brand
before
new light rail.
they open a
Our
section.
team makes sure that the intent is met, making sure that from the different disciplines, the traction power, the train control, the communications, the structures, everything is working individually as it should.
And that every individual component and system works together as a whole. After hundreds of hours of testing, the Cross Lake connection will open in 2026, transforming
It has
how we
opened.
move around the region for generations to come.
My favorite part of the job
I said it before, but the amount of tests is absurd. I had to witness a ton of testing for the Northgate Link extension, for the Redmond Link extension. They test God and everything, and everything gets recorded. And it is, just watching over my own subsystem, I didn't get to watch some of the more advanced integration testing because I was a junior engineer and I did, focused on what I was learning and all that sort of stuff. But it is amazing. I spent dozens of 8-hour shifts where it's like, okay, we're just going to the railroad today and observing the testing, and it is making sure that everything's getting done properly. And the folks that do the testing are some of the most wonderful, great people in the world. I loved the test teams I worked with. They were a bunch of great people, and they did a fantastic job. But, man, what a ton of work. It turns out that building a giant piece of infrastructure is complicated and takes a lot of time. And when, you're talking about the safety of all the people riding, you want to make sure that everything works absolutely with all the I's dotted, all the T's crossed, the whole thing. And yeah, it's a lot of work to get that done.
is seeing at the end of it the people riding the train, the difference that we make into people's lives.
I'm probably luckier than I am smart. And just to have been in the right place at the right time to work with some incredible people.
That's not just stock footage. That's my old boss. Hi, Craig, if you see this. He was deputy director of the department I was in when I worked there. I think he's the director now. Absolutely great guy.
We said, never been done before.
There he is. That's my old office.
How can we use
I used to sit. That might not be the chunk of office I was in. Again, I was only there for like 6 weeks before COVID kicked off, but it looked a lot like this, and my spot was over there somewhere, I think.
Do it.
How can
It's
we
been a long
use
time.
existing infrastructure to continue to expand transit? That's really the key here. And the floating bridge is just one piece of that.
I'm very proud, but I'm also humbled by what the art of the possible is when people get together and work together. And when your job is to connect people, we're really creating community and then connecting communities. And to me, that's priceless.
So, I mean, that's very obviously like a big PR piece pushed by the agency Sound Transit, of course. And it's very feel-good nature in that, hey, we finished the project. And, you know, they're definitely pushing that pretty hard. But at the same time, they should, because what a cool thing. Discord user Bandan, who's a longtime channel member, went to ride the first trains on the day opening and said that the line to get on at not even the start station, not even at IDS, the International District Station, said that the line was something like a half-mile long, and they were running trains at like a 6-minute headway, so 6 minutes between trains, and big 4-car light rail vehicle trains, and it took a while to get everyone on because everyone was so excited. And it's such a cool thing, and such a vital link literally for the Seattle area, and it's so fantastic to see that it's open and working, and that all the hard work finally paid off. There were plenty of challenges getting it opened and all that, and that's the joy of any big infrastructure project. But the amount of cool engineering that went into solving these problems and getting this service opened is truly fantastic to see. And all the people involved were absolutely lovely. So it's great that this is now something that exists in Seattle. We have light rail trains that run on a floating bridge. That has never been done. That is so cool to think that right in my old, backyard where I grew up, there's now trains that run there. And I had a little piece of it. I mentioned it briefly, and they didn't really get into the train control stuff again because black box, it keeps the trains safe. How? Most people don't know. What are you gonna do? The engineering behind everything was really cool because that is, again, a unique thing, right? No one has run trains on a floating bridge before. What considerations are there for train control, for the signals to make sure that everything stays safe? How can you eliminate as much risk as possible in the system and keep people safe in the event that the worst might happen, right? What would be the worst thing that could happen? You've had a rail split on a floating bridge and then you have a train derail. Ooh, that would be a bad time. How do you protect for that sort of stuff? And it was interesting. The logic for the interlockings. Good heavens. That was one of the most complicated things I've had to review. It was worse than my own century of Steam code, believe me. It was quite a bit to it, where the two interlockings on either side of the bridge, there was diamond crossover on each side. So right at the fixed point, And they had to be special with special low-profile switch machines because adding in that maintenance lane for WashDOT meant that everything was super tight and the track centers were super tight. And in order to make sure the vehicles wouldn't collide with the switch machine, we had to use these low-profile switch machines, which were different, and that brought in different logic and all that sort of stuff. But the two interlockings had to talk. They had to know exactly what was going on, and they had to be able to prevent too much weight from getting on the bridge at the same time. They talked about weight of all of the civil stuff that got added, but when you're talking about 4 fully loaded light rail vehicles, that adds a lot of weight too. And so we had to design for and plan for several different modes to make sure that nothing would overload the bridge, especially depending on condition. So the interlockings are set up to say, hey, only 2 trains on a bridge during normal operation? Great. So that they will prevent clearing another train across the bridge until it has cleared the subsequent interlocking. So if you got 2 trains on the bridge, when one of them finally clears the set of switches on the other side, the interlocking, okay, now you can bring another one on. Which, with the headways they run, you're not liable to see that, but we had to protect for it in case of any kind of odd scenario. Signal design and train control safety design is all about picking out the weird little cases that are going to cause the problem that will cause the incident and trying to eliminate them as much as possible. We also provided for 1 train only on the bridge at a time if the wind conditions were worse and the bridge wasn't able to support as much weight as typical, anything like that, or just totally closing it down and not allowing any routes to be cleared. That was relatively simple, but those are things that can be set and protected for based on what weather conditions are happening. And that way you get safe train control operation across the bridge. And yeah, I mean, the normal logic for an interlocking was something like 500 pages of relay code. For the 2 that were at the interlocking for the bridge, it was like 1,500 each. It was absurd. There was so much extra stuff based on environmental conditions that we had to design for and keep into account as train control engineers. And again, it was designed by a consultant, but it was something that I went through and verified with the help of one of our senior signal engineers, who was one of the funnest and most delightful humans around. My coworker Bob from back in the day. He's just a wonderful guy. He's been in Signals for as long as Signals existed, I think. But just a wealth of knowledge, and it was really fun to go through all that and understand all the logic with him and how it worked. And there's a lot goes into it, so it's just utterly fantastic to see this in service now, given that obviously I only had a little itty bitty piece of it. There's so many people who were involved for decades, and that the project was their entire existence at the agency. And I was there for, 3 years, and probably for 2 years. This was maybe a quarter of my time was this project, if that. There's so many other things going on and all that, but it was just a good bit of fun, and it was great to kind of have that impact on the community, and knowing that, hey, this wouldn't have happened without me too, even if it was just a little piece, right? So I'm doing my part. I did my part, and it's so cool to see that open. And I can't wait. When I next go to Seattle, I would love to try and ride it, because I just want to say I did. And just know, like, oh, hey, these trains run in part because of me. It's less than 0.1% my fault, if I had to guess. But hey, I helped. So it's really cool. And the novel engineering challenges that were solved, and doing a world first, super cool. So hopefully you guys learned something today. Hope you thought this was interesting, and let me know if you'd be interested in more of the transit stuff. We haven't gotten super into that, though we likely will do a little bit more on this front in the future, especially with Leighton threatening to make a video about the history of Denver's transit. We'll kind of see. It's not exactly railroad, but it is very railroad adjacent, and important and key to the community. So it was always kind of fascinating to me, and it's always interesting. So if you'd like to hear more about stuff like this, or more about transit in general, let me know, and we could do some videos like that too. We like all things on rails here. Yeah. Anyways, guys, thanks so much for watching. Catch y'all next time.